Hello, welcome to Manage Program Flow. In this video we're going to cover if statements along with the else if statements, logical operators, switch statements, and for loops. Before looking at any examples, let's talk about program flow. So as of right now in our playground we have this var str equals hello playground. If we go ahead and create another var and say str1 equals hello world, our program is being executed from top to bottom. So we have our str getting executed and then our str1 being executed. Program flow is the order of execution for your application. So using some of the stuff that we discussed in the previous slide, like an if statement, we can change the flow of our application. So we can say if true, execute this statement. So we can say print this statement is true, else print this statement will never get run. And it will never get run because we were saying if true, and true will always be true. And that's why we get this warning here that says will never be executed. So that doesn't really do us any good because true is always going to be true. So let's look at another example. We can say let x equals 5, and then we can say if x is equal to 5, and notice we're using this double equal sign. So a single equal sign assigns a value 5 to x. A double equal sign checks to see if x is actually equal to 5. So if that statement is true, we can print x is 5, and then else, which means it is not true, we can say print x is not 5. So x is equal to 5, so it's going to print x as 5. But if we come up here and we change x to be equal to 4, then x equals 5 is false, so that else statement will get run, and it will say x is not 5. So let's change that back to 5 to make it true. And now let's create a more complicated if statement. We can say let y equals 5. And then we will use a logical operator. So first we will check to see if x is equal to 5. Then we will use this logical AND operator, which is 2 ampersands, and say y is equal to 5. So this is checking to make sure that x is equal to 5 and y is equal to 5. If either one of those is false, then it will not execute this line within these two braces. If they are true, it will print x and y are both 5. Then we can say else print x or y is not 5. But let's check for some other cases. So let's go ahead and say else if x equals 5 and y is not equal to 5, so we use an exclamation point equal sign. Then we can be more specific and say x is 5 but y is not. And let's continue that trend and say else if x not equal to 5, double ampersand, y equals 5. Then we can print x is not 5, but y is. And now for our final else, we know that x and y are both not 5, so we can change that. So right now we have our x and our y equal 5, so this print x and y are both 5 gets run. If we change our y to 4, then we have this else if x equals 5, which is true, and y is not equal to 5, which is true. So x is 5, but y is not gets run. That's this line here. If we change this x up here to a 4, then x is not 5 and y is not 5. So none of these statements get run, but this final else statement does, and it says x and y are not 5. So that's a lot of if statements and else if statements. we can actually use what's called a switch statement to minimize this. So we can say switch, and then we're going to have a tuple with the values x and y, and then we can create these cases and pattern match on what we are switching on. So we are switching on x and y. So now in these case statements we can check if x is 5 and y is 5. If that's true, we can print x and y are both 5. And then we can have a case for our 5. And here we're putting underscore, and this is just saying that we don't care what that value is. So we're saying that x is 5 and y is whatever number. And we can say x is 5, but y is not. In our next case, we can say underscore, comma 5. And this is saying we don't care what value x is, but we want y to be 5. So we can say x is not 5, but y is. And for our final case, we don't care what either of those values are. And we can say print x and y are not 5. So instead of doing this, we don't care what x is and we don't care what y is, we could just get rid of that case and put default. And it will do the same exact thing as underscore, comma, underscore in the parentheses. So a switch statement must be exhaustive. So we have to take into account every single case for the switch statement to run. If we take out this default line and just comment that out, we will get a compiler error saying that this is not an exhaustive switch statement. See, switch must be exhaustive. So this is saying we are not checking for all the values that this switch statement could accrue. So that's why we need to have this default in there. Now the last thing that I want to cover is, so we will go over a for loop. And to demonstrate the for loop, I'm first going to create an array of numbers. And I'm just going to say 1, 3, 5, 6, 8, 10, 12, and 13. And then I'm going to say for number in array of numbers. So what this is doing is we are creating a variable called number, and that number is going to iterate through each of these elements in this array. So for the first iteration, number is going to equal 1, because it's going through array of numbers, which is the array of numbers here. So it's going to create this variable called number. The first iteration, it's going to hold the value 1. And then it's going to run whatever is in here. The next iteration is going to be 3, 5, 6, 8, 10, 12, 13, through each iteration. So the code that we want to execute, we are going to print whether it's an even number or an odd number. So we can say if number, and use the modulo operator, and we're say number mod 2, and we want that to equal 0. If it's equal to 0, it means that the number divided by 2 has no remainder, because the mod operator just gives you back the remainder of number divided by 2. So if the remainder is 0, that means the number can be divided by 2 evenly, which means it's an even number. So we can say print number is even, else we know that the number is odd. So now we should have 1 is odd, 3 is odd, 5 is odd, 6 is even, 8 is even, 10 is even, 12 is even, 13 is odd. And I have a typo here, so we can fix that. And now we get that correct output. There are other type of loops, like the while loop and the do repeat loop, but the most common is the for loop, and that's what you'll see most often. So that's the only one that we are going to cover here. In the next video, we will cover using Swift optionals. See you then.